suffering probably for the heat today. I have the fun, but I don't have it, so that's it. So thank you again for organizing today's event. I will be the last one. I attended some of the previous events, and all of the talks were really interesting, especially the one from different section, different from my geomatics session. So I had the opportunity to have a glimpse of what my colleagues are doing in the department. Today, as Juan Pablo is anticipating, I will talk you briefly about what is behind my PhD work, my PhD research, related to the development of an open source framework for geospatial data, geodata management for both the built and natural environment, with some example and case studies. I'm a third-year PhD student. Currently, I'm finishing my visiting term in Tecne, Autostrade per l'Italia, and I hope that you will enjoy my presentation today. Okay. In the first part, I will introduce you the context and objective of the research of these past 3 years, highlighting the research components derived from the current need identified in different fields, as well as I will identify and present to you some case studies application for real-world scenarios related to civil infrastructure, natural environment, and cultural heritage. And then, in the end, of course, I will discuss briefly about the results, the main insight, with some conclusion on ongoing works and future development related to the current activities. We live in a world in which data is fundamental for any decision-making process, decision-informed process related to different fields. So you can see specific regulation, national guidelines related to data collection for bridge inspection. Recently in Italy, it was issued regulation related to optimize inspection and monitoring activity based on in situ visual data and survey data collected on field. This is similar to the case also of natural heritage, like the one of the glacier. This is the glacier Belvedere that I think most of you know already because it's a long-term project of the department. And also in this case, we need a lot of data of different types, especially its spatial component, in order to understand the behavior of these sites, alpine sites, that is constantly changing and it's probably going to disappear in a few years. And of course, this is also very important, knowing how to optimize this data when it comes to cultural heritage, that is also with climate change, urban development plans, more and more buildings in a urbanized area can be affected by also the effect of human activities. And so we need to understand how to document the states of these heritage sites, as well as what inside also these cultural heritage sites, as the example of the museum. So whether we have to manage the information related to a defect or a damage that have been detected on a bridge or on another civil infrastructure over different inspection, or understand where a point or a specific portion of a glacier is behaving in every yearly monitoring activity, or an artwork or another building element inside cultural heritage site is moved or damaged maybe by environmental condition, it's essential to understand how to manage this data in a proper workflow and in a proper framework that most of the time is a case study specific, with a lot of proprietary software that limit the possibility of an accessible, flexible decision-making process, as well as the possibility of developing stories around the data in order to engage people, maybe in scientific activities and projects, or engage decision makers that are maybe not super expert in technical aspect of geomatics or survey, but are super important as part of a long decision-making process for structures. So these challenges ask for improved technologies of different natures that have to be integrated and produce various outputs in different formats with different standards that most of the time are still not completely interoperable, and that in most cases, as the one highlighted before, are part of proprietary software and proprietary environmental workflow or build management workflow. So the main question behind the research when I started working on this topic related to optimized geodata management and geospatial management was which are the bases, how it's possible to develop an interactive, low-cost and customizable framework that is able to deal both with the semantic information of a specific context, cultural heritage, civil infrastructure, natural environment, as well as with the geospatial dimension of this data over time, and maybe as part of a repeated workflow for inspections or monitoring. When I started exploring the current situation in the real-world scenario, talking with managers of highway infrastructure as well as provincial level and national level, but also what was done before in our glacier monitoring project, the first solution that came to mind to a lot of people was using Excel, or maybe a bigger Excel file. A lot of worksheet, calculation, super complicated formulas, but this is not exactly what we think as geomatician, but also data scientists and other people working with data when we think about something optimized for data, especially when we have to deal with flexible queries of the information that has to be extracted, with complex requests by ever-changing regulation and guidelines. And so I started identifying the small steps that are required when developing, designing, and implementing an optimized, flexible workflow for dealing with two-dimensional as well as three-dimensional geodata that is not limited to Excel, worksheet, or other similar files that most of the time are proprietary files also. And I managed to identify, talking with people working for real with this data in different fields, first step related to the data collection and analysis as well as the data update, because when we have to collect periodically new data during inspection or survey on field, we need to properly create a structure for this data, a metadata for them in order to document the entire process and also prepare them according to available, approved standards and also common state-of-the-art analysis. Then, of course, the development of a structure framework able to deal with the complexity of the data management. So understanding how to store the data, where to store them, how to make them interact with each other, how to integrate different components and different epoch also. As well as the last part that most of the time is not very well considered. We stop at the second step, geodata management. We don't think about the importance of visualization and usability of the final work. Because if it's not accessible, it's not possible to tell the story of what is happening, related to what is happening in a specific field, like, for example, glacier monitoring for outreach and dissemination. As well, it's not possible to develop strategies for valorization of cultural heritage, as well as not possible to develop or improve current regulation or guidelines for infrastructure management. But the main key is that some software, some tools already exist related to these three distinct steps. The main issue is that most of them, based on the state-of-the-art, are proprietary. They do not talk to each other. It's difficult to integrate them. Most of the time, they require a lot of time-consuming procedure in format transformation. They are not compatible with each other and related also to the most common standards, like the one of Open Geospatial Consortium or smart building, for example, for BIM technologies. It's very difficult sometimes to find a common ground for all these technologies and input. So what I tried to explore with my work was to find a special focus on the interoperability of the tools, find a possible scenario landscape of tools and main characters that can be open source, free, or low-coded also. So accessible, limited in cost, and reusable. That is very important, especially for public administration when it comes to adopt specific softwares and reuse specific software for different contexts. And so for the data collection and analysis, I try to test some of the available tools related to the geomatics world when it comes to survey, data collection, geodata collection of field, for both GPS technology, photogrammetric survey, terrestrial laser scanning, as well as data processing and analysis, so point clouds processing, 3D model processing, with some of the software like RTK Lab, OpenDrawMap, and Cloud Compare. Related to the geodata management, I heavily relied on the world of OSGeo, open source Geospatial association, using tools that are open source and easy to implement, well documented, like PostgreSQL, PostGIS, and QGIS, all related to the geo world and the world of the relational database, in order to understand how, without high skills in terms of IT development, is it possible to develop something efficient and optimized for any application. And then, last but not the least, I try to reconstruct an overview of the current technologies employed for developing web viewer, interactive viewer that are able to memorize interaction of the user when exploring specific data, annotate this data, and build the basis and the foundation for more advanced calculation for the application of, for example, other algorithms able to extract information that can be fed into the infrastructure of the database. And so I explored a bit WebGL, graphic libraries. Based on this technology, I accepted the challenge of some of the projects in which my laboratory, LabMGF, is engaged, starting from the civil infrastructure context, as I worked closely with the province of Piacenza, province of Brescia, Tecne, Autostrade per l'Italia, and ADUEA, especially working on bridges, with some works also and testing on dams. Bridges lately are structures of high relevance because of the recent events that most of the Italians probably are aware of, but not only, because in all Europe and also outside Europe, rule makers and lawmakers are developing, discussing new regulation and guidelines and common practices for documenting the state of the bridges. Talking with some of the administration, I had the opportunity and the luck also to meet something that surprised me is that most of the time we think that, okay, we simply have something on Google Maps, OpenStreetMap maybe, where we know the position of the bridge, and okay, once we know the position of the bridge, we know already a lot of the things, or the road in which it is located, if that specific portion of the territory is affected by specific hazard or events in the past. But the issue is that most of the time administration do not have this information. The exact coordinates associated to a structure are unknown most of the time. Most of the data are not digitized, and most of them are fragmented. So it's very difficult to import them in a single place and develop strategies for dealing with this. As part of the collaboration with the groups I mentioned before, I started also experiencing on field what is requested also by the new guidelines in terms of 3D modeling and reconstruction of the structure, in order to understand which are the technologies, the output that we have when we use drones, as well as the traditional topographic measurement, terrestrial laser scanning, and what are the complexity also of the territory. Starting from this, it's currently in progress also the documentation of some good practice and guidelines for people involved in this kind of activities, in order to optimize the collection of data in accordance to the current national guidelines. Current national guidelines, okay, can be optimized for the case of Italy, but in order to have a really accessible, flexible, and customizable framework, is necessary to develop a core structure, identifying the main data needs, not only for Italy, but also for most of the other countries that are involved in this revolution in terms of the reorganization and management of the geodata for infrastructure. So as part of my period, 6 months in Supsi, Switzerland, I had the opportunity to compare and study the regulation, current regulation, requirement for data on field for Italy and Switzerland, for the bridges when documenting the fact, their current states and their technologies that are recommended. And I tried to compare in order to understand both the differences in code, existing software, BMS, Bridge Management System, and also recommended techniques for survey. Starting from this, I managed with this part that is more related to the requirement, user requirement analysis. I found a common ground of data that are requested by both countries, as well as also other European countries with which Italy is aligned, in order to understand what is needed for, in terms of data, for periodic inspection, and also understand how the main core structure of the framework can be in future maybe implemented or expanded for allowing the integration of other data for more specialized inspection or continuous monitoring that a priori do not affect all the structure. And so this led to the definition of a modular design. So not only a single database schema that is valid for all the type of structure, but a system that is composed by different elements that are always there in any case, but can be adapted in details for specific application according to the needs of the final user. So in all of them, however, there should be three main components: the data storage, in which of course I deal with the different information, spatial and thematic information related to the bridge, the structure, not only the single bridge, but maybe also a gallery or a dam. A cloud-based application that also do not require the installation, local installation of additional software or specific licenses and dependencies on the desktop, in which it's possible to explore geometrically the virtual model and all the 3D thematic data that are associated to it, as well as it's possible to interact with it, enriching it with observation of experts that with a posteriori virtual exploration can annotate the effect, damages recognizable on images from drones, as well as extract part or portion of the bridge or the structure. Then the last module, that is the last in order, but is probably the most important when designing the different components of the modular structure, is the readaptability that is closely related also to the usability. So the need of documenting every part of the process, starting from the data collection on field until the implementation of the platform with dedicated instruction for both user and developers in order to prepare the ground for future implementation that do not necessarily rely on the same person, on the same developer that first installed or first recommended a specific software. Starting from this then, for the case study of the bridges, I developed the first ERD schema with entity and relationship to be then implemented with a relational database in which the core element of the entire structure are the inspections, periodical inspections of a structure or survey if it's not something regulated and called inspection, to which are connected different type of data as well, 2D data, 3D data, historical data that maybe were digitized not in a 3D space, but just as an attachment in different format. And also connect this, of course, to the structure itself and also the sub-element of the structure. So, for example, the beam or the pile, in order to have a more detailed also level of information for the users and also the decision maker in order to decide what to do, which plans, maintenance plan has to be applied or are more required. So, starting from this, trying to respect the modular schema identified before, I tried to develop a first prototype for this kind of application with a network level web map. This is the home page where users with specific power and permission can access, edit, update, upload new data, as well as interact with the existing information related to specific structure on the territory. And again, this is all built on open source software like Leaflet and Bootstrap, and allows also flexible querying of data from the underlying database. Starting from there, then users can access also the single structure information with an easy-to-use pop-up where the end user can access easy to read tables with the list of previous operation or activities on a specific structure, as well as can extract in a PDF, because unfortunately most of the regulations still require the input of PDF file, even if it's not a fully interoperable file for most of the software now. Can extract the file in PDF format in order to share it maybe statically with someone else in terms of enhancing team collaboration. And then also can access, if available, for a specific operation on field, like an inspection or a visual inspection, can access also the 3D data associated to that specific event in a dedicated viewer that is built again on open source technologies with WebGL, like in this case Po3 and Cesium.js. The code is locally available on my GitHub repository here. And from here, users can access the point clouds directly reconstructed from the surveys. Can see also if the specific point cloud previously was already annotated in terms of defect detected on specific images, and can also access specific images orientated, drone images that are orientated on the model, so that maybe using the trace of a 2D image it's possible to reconduct the geometry to the 3D structure without having super skill for exploring the 3D model, as well as, of course, annotating defects that are recognized or element of interest, maybe for a future intervention, annotating a specific file and telling the operators on the field, check if that file is annotated in order to better coordinate future intervention. This is possible thanks to the seamless connection of the viewer with the database behind the relational database, so the cloud application with a component with the database data inventory module, and this allows, of course, according to the permission of the users logged in, allows to create, read, update, and delete any annotation on the viewer. Starting from this, however, thinking about what we had this project also in our lab, we thought that probably it was an interesting playground to test also the case studies of the Belvedere Glacier. That is a long-term monitoring project that is active here for the past 10 years. I see some of them attended also previous summer school edition. And in these years, in the last decade, collected a lot of data. Even more than the bridge I had the opportunity to explore and investigate with the public administration. Every year we collected the information about the location, the coordinates of specific points, ground control points along the glacier, in order to compute years after year all the displacement, velocity, and acceleration of portion of the glacier in order to understand what is happening to this natural heritage. The main difference here, however, is, of course, the type of environment that is a very impervious environment most of the time, is constantly changing, and every year it's different also to approach the site, but especially the target is very different, because in this case we involve students from bachelor and master, not public administration technician that maybe have a bit of knowledge of geomatics or technical aspect of a web application. So students that are learning something related to geomatics, geoinformatics, sometimes civil engineering, or also architecture. But also other researchers, not necessarily from Polytechnico, that are not from the geomatics field, so they know how they have the need to easily access the raw data with all the information related to how they were created, which is the resolution of specific product, both temporary and geometric resolution, and also access in an easy way the database or any data inventory related to the data collection of our project. And then, of course, something that is probably even more important when we do research related to local communities, because there's every year we are welcomed by the people of the Alpine Hut of Macugnaga. We also have interaction with the local community of Macugnaga that is not that far from where I live. And so it's very important also to give something back to the community in order to let them understand what we do every time they see us with drones around the glacier or with strange instruments and equipment. So we identify 3 main targets: students, someone internal to our universities, researcher, not only at Polytechnic but also outside, and also a general public. And so it was not enough to have a single cloud application with a single way of accessing the data, querying the data, updating them like the cloud application of before. But it was needed to develop, starting from, of course, always a relational database with periodic data collection, documented, develop some more complex platform with an expanded modular system, starting from a dedicated module that is not only a viewer, but also data related to learning resources related to the summer school. Every year they are produced, there are different materials that are produced related to GIS technologies, drones, photogrammetry, GNSS, and laser scanning, as well as techniques, traditional techniques for monitoring glacier. And in this case, having open access also for learning material is something that was considered very important for the project, and so we developed this additional module in addition to the main cloud application, where users, maybe students or other people interested in learning something related to the project, can access the data, can access not only the data but also the tutorial, the webinars, and all the documents related to the teaching, as well as accessing directly the data. Indeed, this tutorial also includes some guided exercises with instruction on how to access the Postgre database that is behind the entire cloud application website that I will share with you in the next slides, the QR code. And so, starting from there, this is an access point, an entry point for any background users that is interested to know more, and also maybe in the process learning more also about some of these IT technologies. That, of course, represent the basis also for the other 2 targets, strategies. The first one is the scientific dissemination for researchers in the field, glacier monitoring, so not only geomatics people working with GPS or drone, but also glaciologists, geologists, and more, that are interested in accessing not only the data inside the database with the structure that is derived from also the one of bridge inspections, but also query them in an easy to access way. So the viewer is developed with a different design in order to easily query and visualize in 2D in these cases some information related to point measured along the glacier, as well as product, intermediate product like DSM, digital surface model, and orthophotos, other information that can be derived from every year survey. That can be accessed also with desktop application, because maybe for this case, for this target, it is needed to compute additional processing or analysis on QGIS, to compare or other softwares, as well as to directly download also the data locally in order to perform directly their other improvement, or also document issues that maybe while using the data have been detected. And finally, the general public outreach module on the web application, where again a 3D WebGL is developed, and we're connected to the database only through only view permission, allows everyone to access a 3D view with point clouds from different epochs since 1977, allowed to access the point clouds, measure them, extract cross-section, as well as to interact with them and see where along the glacier points were measured, so coordinates, where the coordinates were measured. And once maybe identify a specific year of interest, it is possible not only to select the survey, and so loading the point clouds seamlessly on the web with a simple internet connection, but also load points measured and see directly there in a virtual exploration, posing the basis also of a possible environmental digital twin, access the dashboard of the measurement in terms of velocity, displacement, and acceleration associated to specific point. And so this comes always with a readaptability and reproducibility open source code with a user exploration guide that supports the user in the whole experience, considering that in this case we don't have experts of geomatics data. Finally, this approach was tested also in Piacenza for 2 cultural heritage sites. So we saw a specific case of built environment, but the idea was to test it also for other type of structures, not only related to highways like bridges, but also cultural heritage sites that maybe are affected by stories or are the protagonist of stories that a particular value for the local community, like for example Farnese Castle, that is unfortunately and sadly remembered because it was the site of the first COVID hospital, field hospital during the COVID emergency, and in the past years went through a lot of studies and assessment of possible strategies for trying to valorize this site and also to narrate this site to other people. So developing, starting from historical 3D models of how this castle was first built in different steps and then destroyed in other steps, so layering this information inside the underlying database with a dedicated 3D model reconstructed, as well as point clouds of direct survey. It was possible to develop an exploration tool as requested by the association that is taking care of the site in order to tell the story that is behind these walls and this site that now is also occupied by the army, so it's not freely accessible on an everyday basis. And so in this case, it was developed the viewer, always connected with a simple viewer without any specific data exploration, because the target here was only the general public, using high precision and high quality geospatial data from the field, as well as high detailed reconstruction of the historical steps of the construction and deconstruction of the site, with some easy to use tools for the exploration in 3D. As well, again, the code is freely available, and in this case, the data combined related point clouds, oriented images from drones, used also for the reconstruction for both the outdoor and the indoor environment, where some annotation with pop-up of images or other multimedia were integrated with simple requests from the database, always maintaining the thematic information for narrating the story, as well as spatial accuracy of the information. Finally, eventually, we have the last example of the Riccioli Gallery, where similar needs were shared with us by the manager. But in this case, there was also the need to understand how to optimize a virtual tour inside the gallery. That is a specific architecture, quite complex architecture with many rooms interconnected within them, with also a lot of artworks that are well documented in the National Archive of Cultural Heritage, but some of them are not unequally reconnected to them. So there was this also need to understand how to restructure a database and maybe also enrich it with information that are also crowdsourced. So testing also some integration with OpenStreetMap and Wikidata, so some sources of user-generated data for enhancing the experience of exploration for user. This gallery that was, again, always surveyed with UAV photogrammetry, terrestrial laser scanning for the outdoor, and for the indoor with SLAM technology. So, again, the output and the processing of this software, of this product was tested before in order to understand how to put them inside the database, schema developed, and luckily everything was compatible as designed. And so it was possible also to integrate images and pop-up in order to enhance the experience. Now, future step regarding this require also the development of a dedicated user management system because they want now to renovate some areas and want to document also all the renovation phases. So there will be an artwork component for the outdoor, for the communication to the external public, and also something more technical for authorized users. So this will be another challenge. Jumping to discussion and conclusion, what is currently developed is this platform prototype, modular platform prototype. I didn't look deep in details of the technology, but if anyone is interested, I will be more than happy to talk with you in order to understand user need, implement maybe functionalities that is able to deal with different input with related to different approaches and technologies for data collection, such as point clouds, 3D models, vector data also, as CAD is a highly used very used format for especially bridges, and also geonotation as well as oriented images from drone. And having this with the modular structure developed for testing also in different case studies, it was possible to improve team collaboration, tell the first feedback, as well as having a dynamic viewer that does not require graphic components in the laptop, personal laptop, and does not require to install anything locally, as well as the ability to have a toolkit, simple to use toolkit for extracting measurement or other insight from the data visualized, as well as a dashboard. Building also the foundation with structured data and documented data also in terms of metadata for building more advanced application also related to digital twin technologies. Current potential is, of course, related to the data integration, heterogeneous data integration, having survey products, time series from periodical measurements like glacier, but potentially also is something that I'm testing with Techne, also periodical measurement and observation of sensors in a monitoring campaign, and also the possibility to integrate in the same environment, in a single environment, post-process 3D product like meshes, as well as IFC, that is the most common standard for BIM modeling, especially in case of bridges. And then also the other core potential is related to the reusability of everything. During the application and testing, I always try to document as much as possible everything, because as an open source users and contributors, something I always have a problem with is finding documentation. That is the main problem when we use this kind of data and products also. And so the idea is to have a generalized database structure that can be reused and reapplied flexibly to different contexts without having the need to restart from the beginning, always with a new design, a new user requirement phase, and starting from scratch with the design and implementation, thanks also to the modular architecture that is then implemented in the prototype with free and open source tools that can be freely used and tested by everyone, so always looking for feedback if anyone is using this kind of tools. And also through the updated and constantly updated community documentation that simplify the access to these technologies, also engaging more people and creating more knowledge also related to this topic, for example, related to general outreach, but also allowing the development of specific skills with dedicated training documents. So the initial feedback, now particularly now in testing also with Tecne, the structure related to bridge, that is a national level organization, so it's way different from provincial level organization, but the challenges are basically the same most of the time, so it was interesting to see the first feedback on the viewer and especially how to deal with the images of documentation of damages and defects. And now they suggest that this represents a flexible approach in which we have open source technologies, low-code technologies that they can also try to implement by themselves thanks to the documentation, and also that can represent a valuable alternative to existing proprietary software that most of the time do not have an interoperability. However, still some limitations exist. Most of them are related to the data storage and also to the needs of dedicated server that, of course, are costly. So currently also the efforts are in the direction of documenting the workflow in an even more accessible way, not necessarily only on GitHub, as well as testing some virtual and augmented reality possibility related to the technologies that are already present in the prototype, like Cesium.js, and finally also try to standardize the sensor observation stream inside the viewer with some OGC standards API. In case anyone is interested, some selected publication related to this work. And if you want to know more about some of these projects, we had a seminar related to the glacier monitoring for open data and open technologies that are behind the project, again, with the goal of engaging more people in this process, and also another short webinar related to the tools for the web viewer, so more in detail if you need something more technical related to the viewer and how it implements everything. So I hope that with this work I managed to highlight how it's needed to have structured data. Sometimes it's something we don't think too much about and we take it for granted, but when talking about digital twins of different types, this is the most important thing, having something efficient and optimized as an engine behind our data, that without it is very difficult to understand their meaning and extracting valuable insight. So thank you for your attention and for surviving the heat.